ever been hanging out in nature and wondered why this fungus grows here in the shade and not just back there in the sun? And why do these grasses grow here and not over here? Let's get some answers in today's episode all about microclimates. Before we get to answering those very important questions, we need to set something straight: the difference between weather and climate. Weather is the minute-by-minute changes in the atmosphere. Weather is constantly changing, like all the time, every day. For example, just because it's nice and sunny today doesn't mean that crazy wind won't roll in or a thunderstorm might pop up. Now, climate is what the weather is like over a long period of time in a specific area. And while weather can change in a few hours, a region's climate can take hundreds, even thousands of years to change dramatically. I've heard it best described like this: if weather is your mood, then climate is your personality. So weather is quick current conditions, and a climate is the average condition of an area. Now that we got that out of the way, let's take a look at microclimates. So what's the difference between climate and a microclimate? We just learned that climate refers to the average temperature and precipitation of a region, which is a large area, but a microclimate is a small area that differs from the regional climate, often slightly, but sometimes dramatically. This smaller area can be as small as a garden bed or as large as several miles. The most important thing about microclimates is that they allow greater biodiversity. A single species may only tolerate a limited range of climate. The addition of these pockets of significantly different temperatures and moisture levels provide a varied environment where a rich community of organisms can form. A difference in temperature and humidity define a microclimate in a certain area. These changes can be caused by a wide variety of things, but here are a few. Plants of all types can help regulate the temperature of an area by providing shade. Vegetation can also help maintain higher levels of humidity in the air. Through a process called transpiration, plants release moisture, making the surrounding air more humid. The way the earth rises or slopes greatly impacts microclimates. Caves are important geological formations that can house unique environments. The mixture of water content within the geochemistry of the rock, cave atmosphere, and air pressure can combine to make unique microclimates within the cave system. Temperature normally decreases as elevation increases. Air traveling up the side of a mountain becomes colder and thinner, often releasing moisture in the form of rain or snow. As the air moves down the other side of the mountain, it is heated and compressed, producing drier, hotter conditions. Another contributing factor is the aspect, or the direction a slope faces. Slopes that are exposed to more direct sunlight are warmer for longer periods of time, giving this slope a warmer microclimate than the opposite-facing slopes and the surrounding area. Another feature is the ability of the area's soil to absorb and retain moisture, which depends on the composition of the soil and its use. For example, sandy soils warm up more rapidly than clay soils because sandy soils don't hold their temperature as well. Artificial structures made of brick, concrete, and asphalt, like this bridge behind me, absorb the sun's energy, heat up, and then re-radiate that heat into the ambient air. Urban areas experience this heating up the most. The urban heat island effect is when urban areas become significantly warmer than the rural areas surrounding them. If you're still here liking this video, let us know, and hit that subscribe button so you never miss an episode. Now that we know what defines and impacts microclimates, let's see if we can find some examples out here. With me, I have a few tools that we will use to measure things like the amount of moisture in the soil, the ambient air temperature and humidity level, and the amount of sunlight. Our first microclimate is going to be here in the shade, under this giant tree. Check it out. If you look around here, everything is shaded. You can see it here behind me, except for this little spot right here that is in sun. So let's do some measuring. Let's see how this microclimate is going to differ from others. Let's use some of the tools that we brought to take some measurements here in this microclimate. First, we are going to measure the soil moisture. This soil is very saturated. Looking at the ground, all this leaf litter is probably helping to trap that moisture. The ambient air temperature is almost 80 degrees Fahrenheit, and the humidity level is a comfortable 42%. I'm interested to see how those measurements compare to other microclimates. The light meter is reading 1,371 lux, which is pretty low for outside. I'm going to keep track of all of our data here. I just found another microclimate. This open field here is another great place to get some measurements. This area is getting tons of sun, so I'm excited to see how different our readings will be. The soil is just barely above dry. It looks pretty sandy and full of gravel. It's much warmer here as well, 87.4 degrees Fahrenheit, and much less humidity at 37%. Which makes sense because there's no leaf litter or large plants to add or trap moisture. It's difficult to see, but our light reading is at 758,000 lux, super bright. Here's how our microclimates compare so far. Let's use this man-made bridge as another microclimate. The bridge is made of metal and wood, surrounded by concrete, and crosses over a creek. There is no soil to measure, but how does it compare in the other areas? 93.6 degrees Fahrenheit is hot. The high temperature for this area today is reported at 87 degrees, so that's much hotter. 21% humidity is very low, especially for being right by a water source. We also have the highest light reading for today at 783,000 lux, which might be caused by the reflective surfaces. Here is how each microclimate compares. Go outside today and see how many microclimates you can find. There's a link to this resource somewhere down there. And if you want to learn more science, you can check out this video next.